All right, welcome to lab number one, which is safety and fundamentals. And so, if you've been in a lab at Northwest, you've heard a lot of these safety rules already. You're responsible for reading through all of those before you take the safety quiz, which is also the safety contract, which is due um, the day of your lab. So, make sure you act responsibly in lab, follow lab procedures, monitor experiment at all times. Question number Item number seven, you should notify the instructor immediately of any injury, spill, breakage, or health-related issue, no matter how minor, because some of those things I have to follow up on and do paperwork. If you do break something, I'm sure it mentions it later, ask the TA or the lab instructor to handle that because a breakage is not paperwork. A cut is paperwork. So we can pick up your mess for you. In the safety walkthrough video, you saw where the fire extinguisher, fire blanket were. You saw where the three exits were, the three door exits. Remember that the balance room is not an exit from the building, so you do not want to go out through that door if you're trying to exit the building. I also showed you where the eye wash station and safety shower were in those. With the fire extinguisher, I will ask when we do meet in lab if you've used a fire extinguisher because I will ask the closest person that's used one before to grab that. So make sure you read through those instructions. Fire blanket, if your hair or clothing are on fire, you should stop, drop, and roll, and then another person will retrieve the blanket and wrap you up to extinguish those flames. Eye wash station, the important part on that is if you do splash something into your face, you go to the eye wash station with your goggles on and you thoroughly wash your face before you take your goggles off. And then you're going to rinse your eyes for a minimum of 15 minutes. Normally, we recommend 20. Safety shower, we also have in there for chemical spills and burns. So we are going to try to maintain your modesty, but I am more concerned about maintaining your safety than your modesty. So please try to keep chemical spills off of your clothing. Notice in that first bullet item there that we are going to be standing for several hours. So you want to make sure that you are ready to do that. So you cannot sit on the laboratory benches, and most of the labs don't last the 3 hours anyway. You should never eat, drink, or chew gum in the laboratory because that could pick up contaminants, and you should not put food or drink into laboratory glassware either. If you bring food or drink into the laboratory, you're going to be asked to take it out. Any items pertaining to food or drink cannot be thrown away in the lab trash cans either. Make sure you keep your hands and writing utensils out of your mouth during the lab because that's also a contamination issue because you don't know what's been on those lab stations. And you should always wash your hands immediately before leaving lab. And that seems like a small thing, but there are some of the metals, some of the inorganics that in small amounts can cause health issues. Dress properly for lab. Make sure you're completely covered, as I mentioned in the syllabus talk. Baggy or tight fitting clothing are not appropriate lab wear. You shouldn't have your belly showing. You shouldn't have your back showing. Usually not an issue at the beginning of the spring semester, becomes an issue as it warms up. Goggles must be worn at all times in the lab. So when you're asked to wear them, please have them on your eyes. If we are going to do an experiment that involves noxious odors or dangerous vapors, we'll do those in the fume hoods. Stock bottles will be located in the fume hoods. Please only take the amount that you are asked to take. So if you're asked to take 5 mils, don't go over and get 50 mils because we can't put it back in the bottle. We will have to figure out a way to dispose of it. So make sure that you're cognizant of that. We do have waste containers in Chem 2 lab. You'll be utilizing those a lot to put your waste into. Occasionally, you'll be allowed to dump it down dump it down the drain. Make sure that you're listening at the beginning of the lab so that you're aware. And if you forget, please ask. I'd rather you ask than put it in the wrong place. Should not handle broken glassware. And if you do find a crack or a chip in your glassware, then I will allow you to put it in the broken glass box. But you should never put glass into the regular waste baskets. The wash bottles have deionized water in them. Do not put tap water into those. Make sure you do not put anything into those, like a pipette. Burns are the most common injuries in the Gen Chem lab because cold glassware and hot glassware look the same. Hot ring stands and hot plates look the same as the cold ring stands and cold hot plates. So just always make sure you bring your hand close to it before touching it or handling it. And if you do get burned, please let me know, and I will follow up with that. Don't leave flames unattended. Keep the balances and balance room clean because there are a lot of labs running through Gen Chem 2 this semester. Make sure your work area is clean after you're done, and you want to make sure you also keep your work area neat because if you spill something, the water could evaporate and it could become more concentrated. So we want to clean that up immediately. Also, backpacks and other things that could be tripping hazards should be placed either under the coat racks or back in the balance room so that they don't become a fall hazard. Here is the safety contract. You do not need to print that off. That safety contract will be found in the safety quiz. So that's where you'll be completing that. And that is what is due the day of your lab. Now, as far as the other piece that's going to be due, we're just going to be talking about laboratory fundamentals. And so there are some words that you'll need to know. You'll want to make sure you read through this. So I'm not going to read this all to you. You're educated. But accuracy and precision are different. Accuracy is how close the result comes to the accepted value, and precision is a word that is often misused because it is the numerical closest to two or more values. So a lot of times people might look at a balance. So like for instance, in Gen Chem 1, the balance is read to 4 decimal places, and they might say that's a precise balance. And that is a misstatement. That is a certain balance. So you can look at those examples and determine if they're accurate, precise, or both accurate, precise, or neither accurate, precise. So look at those examples on your own. Now here's where, oh, there's a typo right there. Rules for counting significant figures. So when you report numbers, you should report them to the correct significance. So up here, where it says 0.99998877, that tells a scientist that the instrumentation used to gather that value is very, 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 very certain. And I don't know as we have any instruments on our campus that are that certain. And so we have to use significant figures to show a scientist how certain it is. So there's your rules for counting sig figs. I'm going to be perfectly honest with you. It's not a big deal in Gen Chem 2 because most of the time you're going to be using measuring devices that go to 2 decimal places. So if you record up to 2 decimal places in your answers, you're going to be good. So really, you don't need to panic about significant figures. When you're adding and subtracting, the sum and difference may contain the same number of decimal places as the least precise number used. So if you look at this example, the first one, 13.41 has 2 decimal places, 41 has no decimal places, and 3.015 has 3 decimal places. So you're going to go ahead and do your calculation, get the number on your calculator, and because 41 centimeters had no decimal places, then your answer can't have any decimal places. And then when you've truncated it the way you are supposed to, then your final answer is going to have 2 significant figures total. Multiplication and division, when you do these, that it's the same number of significant figures as the least number of significant figures. So in this example, you had 4.6 milliliters and you had a balance that was 12.45 grams. So to calculate density, it's grams divided by milliliters, and you come up with 2.707 on your calculator. But because 4.6 only has 2 total significant figures, you have to truncate that to 2.7. When you do perform calculations and with significant figures, you keep track, but you do not truncate till the very end in terms of making sure you have your significant figures. Now, when you're going through and looking at the different devices, we have digital devices and we have analog devices in our labs. And so we have, well, number 4 didn't come out very well, did it? On these particular devices, you have to, if they're digital, you report every number that you're given. And so let's go ahead. So the analytical balance, which is number one, you're going to report 5.344 grams. The number of significant digits there is 4, and the number of decimal places is 3. So these digital ones are pretty easy. The most difficult one is probably that stopwatch. That stopwatch is showing 10.88 seconds. It's just hard to read as to what the unit is. Number of significant digits is 4 because that 0 is captive, and the number of decimal places reported is 2. And so those are the things you want to keep track of if you have to do multi step task. You want to keep track of the number of safe digits and decimal places. Now, analog devices are a little bit more difficult because your certain digit is going to be the last one that's measured on the measuring device. So in this figure, we have all of these measurements. Now, we have 800 and we have 900 that are actually marked. Now, we have to go by tenths. So the certainty on this is 100 milliliters. So we know for certain that it's either 800 milliliters or 700 milliliters. We can guess the next digit. And so that's what we call the first uncertain digit or the estimated digit. Now, notice this paragraph right here. The 850 mark does not assist. And so in order for it to assist, it would have to have the next place over. So for instance, 800, 900 is the hundreds place. If it had a marking for every tens place, that would be the certainty. And it has to have a marking for every tens place. So here are some different measuring devices, and boy, these are all over the place, aren't they? Okay, so figure 1. Now, what we're going to look for here on all of these is we're going to look for the certain digit and the first uncertain digit. So we're just going to look at these devices and kind of write on them. So with this one, we're measuring centimeters. And so centimeters, every tenth of a centimeter is marked. So every 10th centimeter is marked. So then your uncertainty is going to be the next place over, and it's going to be 0.01 centimeters. Okay. This is not working well since I'm on in a Word document. Okay, so let's look at the thermometer. The thermometer is every degree is marked. So every 1 degree is marked. And so then your uncertainty is going to be in the 10th degree. So when you report from an analog device, you report to that uncertainty. Now this one is kind of like that one we just looked up above, except that every 10 is marked. So on this figure right here, your certainty is 10 milliliters, and so your uncertainty would be 1 milliliter. On this grad cylinder, every 10th of a milliliter is marked, so your uncertainty is 1 more place over, so every 100th of a milliliter. Now, we get into some funky ones down here. So on this one, you'll notice that every 2 tenths. So we have 23, we have 24, and we have 25 marked, but it's 2 tenths in between. So every 1 milliliter is marked because 23, 24, and 25 are marked. And then our uncertainty is actually going to be our 0.1 milliliters, because the fact that there's only 5 lines in between, that marks every 2 tenths, and that doesn't count. Same thing over here on this one, and I need to move this object. I can move it. I guess I'm going to have to move this one, maybe. And I did move it. Okay, so this is the blue one here, and this one, same thing here. Every milliliter is marked, And then you notice the half milliliters are marked, so you can only go over one more decimal place for your uncertainty. The last one on this page is what we call a volumetric flask, and volumetric flasks are designed so that if you get the liquid exactly to the meniscus, that one's a 25 mil volumetric. You can report that as 25.00 mils. That is the only volume you can measure in a volumetric flask is the one it's designed for. Okay. All right. So the number of significant digits reported in that 25.00 is 4, and the number of decimal places is 2. So we're going to use a lot of burettes this semester, and burettes are going to be they're going to measure the 2 decimal places, as I mentioned. So what I'm going to want you to do for the lab. Actually, we'll cover this on as a review. So we'll cover these 2 questions as a review when we get back. So next week we'll do problem 1 and problem 2. Now, if you need help on the extra document, you'll have 3 days to do that. So you'll have till Friday to do that. I do have office hours on Wednesday from 12 to 2. That's not going to help those of you who have the Thursday lab. And so if you do need help on that, I want you to look at that. And then those of you on the Thursday lab, as long as you correspond with me prior to the due date, I will allow a late submission. So just make sure you look at that ahead of time. And you're always welcome to email me questions. When you email me questions, screenshots of what you're having questions on are wonderful. So anyway, that's all I have for you on that lesson. Please reach out if you have questions.